Hello, this is a Module 3 Investigation 2 Function Relations and Domain of Functions. So, in the previous investigation, we wrote formulas to describe how the values of one quantity are related to the values of another quantity. We said that the dependent quantity is a function that independent quantity if every value of the independent quantity produces exactly one value of the dependent quantity. So, this is actually very important definition of the functions. Okay, so please keep looking at that. So it is also convenient to say that the value of the independent quantity are input into the function rule, and the value produced from the applying the function rules are output value of the function rules. So the function has three parts, which is the domain, which is the value of the independent quantity, and the range is the value of the dependent quantity, and the rule, which is the formulas. Okay, you can just see that as a formula to find out. And then the rule of the function cannot be expressed using any word description. Also, algebraic expression, graph, or table of the value. The rule of the function define how a function independent and dependent quantity are related, as their values change together. Okay, so in number 1, we're going to talk about the still from the parameter. Okay, so we used to say that the parameter was 4s, right? Which is there's actually a relation between the side of the square and then the perimeter of the square. But in this case, instead of the p, I'm going to use f of s, which is the function notation. We use f or g. And then, which means I can replace f of s for the 4s, which is s is actually the independent quantity, and then the parameter, which is f of s, is going to be the dependent quantity. So read the definition number 1. Read the definition of the terminology overview above, which is what does the f of 5.8 means? It means it's a parameter of a square, which is in here we're using the inches with the side length is 5.8 inches. And then give the squares a perimeter cannot exceed 48. So, which means perimeter cannot be more than 48, which is less than equal to 48. Of course, it has to be a 0. And then perimeter was, we can say as a 4s. And then we are looking for the square side length f divided by 4. And then side length should be the 0 to 12 inches. And then what is the possible value of the perimeter can be taken? So since the perimeter was the same as f of s, which is still less than 48 or equal to or greater equal to 0. Okay, so that's what it is. And the C, what is a rule that determines how S and f of s relate and change together? So P was same as a 4s, but instead of P, we can use f of s, which is the same as a 4s too. And true or false, that in the function f, there will be exactly one value of f of s from the s. Yes, it is, because the parameter is the function equations. All right, number 3. Recall the box problem in the module 3 investigation 1. Use a function notation and the function name f. We define the box's volume f of x in terms of the side of the square cut out x, which was f of x equal to x times 11 minus 2x times 8.5 minus 2x. So what is the independent quantity, which is in here? We're going to say represent the length of the side of square cutout. And number 2, what is the dependent quantity, which is f of x, which is a volume of the box. And what is the root of the function, which is the formula x times 11 minus 2x times 8.5 minus 2x. Now what is the domain here? As you notice that the domain will be the x, so must be greater or equal to 0. But also it can be exceed more than the half of the width, which is 8.5 over 2, which is 0x. Cut out should be the 4.25. Okay. And then explain the meaning of each of the following. So we just need to find the meaning. All right. So what does the f of 1.5 mean? It means the volume of a box with the length of cutout is 1.5 inches. The same here too, okay? That will be the volume of a box with the length of the cutout is 3.62 inches. And then number 3 means now you have an equation. So the volume is 57.408 cubic inches as a box when the length of cutout is 2.3 inches. So same as the number 4 too. So number 4 means the volume of the box is 3.444 when the length of the side of the cutout is 4.1 inches. See, what does it mean to follow the value of x or such that the f of x equal to 50? So which does means is the volume of the box is 50 cubic inches. Then what is the length of side of cutout? All right, when you look at the D now, it says f of 2 and f of 1. So 2 and 1 is going to be the length of cutout. So we are looking for the difference of volume of the boxes which are cutout is 2 inches and then 1 inches. So the formula with the function notation, so that's the formula we have, okay? So which is this is a formula and which is same as the volume, and then this is we call the rules, and the x is the input. This whole thing is gonna be the output, and then that's a relation here too. So f of x same as of v. All right, now number 4. Billy is walking from the front door of his house to bus stop, which is 960 feet away from his front door. As Billy walks out his front door, he walks in a straight path toward his bus stop at a constant rate of 7.5 feet per second. So illustrate the situation with a diagram and define the variable to represent the value of the relevant varying quantity. So in here, I want to say that, okay, so this is the Billy is walking from his home to the bus stop, and then total distance between the bus stop is 960 feet, but he's walking toward the bus stop, so let's say he is here, okay, and then he's walking toward the 7.5 feet per second, so distance he walked from here to here, his distance is 7.5 t. And then B, define a function f to be determined the Billy's distance from his bus stop in terms of the number of the second he's been walking. So we are actually looking for the distance from him to him here. So the distance we have to looking for is, of course, total distance 960, but he getting close by the 7.5 per second. So what is the independent quantity, which is a t, which is the number of seconds he walks. And then what is the dependent quantity, which is a d, is the distance. So for the time, actually the time that he need, of course, is going to be 0 seconds from the house, and then while he was walking, he get close to the bus stop. But total distance was a 960, and then each of the second he go to 7.5, and then if you simplify it, it goes with a 128 second takes to get the bus stop. But the distance, of course, is a d, but he's there from the 0 when he get there, but it's from the 960 feet away. What does the following represent f of 0? So this is a distance when he was in the house, right? Which is he hasn't gone yet. And then f of 60.25 means it's a distance when he walk 60.25 seconds. Okay, alrighty. Okay, let's look at another problem in the F. So use a function notation to represent the following. Billy distance from the bus stop after he walked 23.6 seconds, which is they're asking for distance, so f of 23.6. And then number 2, represent using the function notation to change in Billy's distance from the 35 seconds to 48 seconds. So f of 48, f of 35. And then G, if the t represents the number of the seconds since the Billy left his front door, solve the f of t equal to 150. So f of t was 960 minus 7.5t. And then you place a 150 for the f of t. And then you just need to solve for t. And then t equal to 108 second takes. Okay, now I want to talk about vertical intercept of the function. So vertical intercept means a function is a vertical intercept is a function output value when 0 is input to the root of the f. We also said that the value of the f of 0 is a vertical intercept. So vertical intercept means it is y-intercept. Okay, so where you get the y-intercept? You always plug it in 0 in the function to the plug it in. So I'll do the number 6, okay? So if the function h defined as h of x equal to 39 minus 6.5x represent the distance between the torus and hare, as they running 100-meter race, what is a vertical intercept? So vertical intercept means x is always 0. So 39 minus 6.5x, which is a 0. So come out as 39. So 0 second, they are the 39 meters away. And B, construct the graph of h, the label the vertical intercept of the h, okay? So when x is the second, which is time, and then the verticals are the distance. So 0 second, they were the 39s away. And then if you, every second, you reduce to 6.5, it takes actually the 6 seconds to do it. All right, so you get this kind of the graph. Okay, so that's the graph. And then what is the point of the 0 and f of z, which is this one? Which is it's gonna be the vertical intercept. It's gonna be the vertical intercept, same as a y-intercept, which means the distance between hare and torus is 39 meter. Okay, All right, let's look at the horizontal intercept. Horizontal intercept we call the x-intercept. Okay, so a function f is a horizontal intercept, so input value where the graph of function f crossing the horizontal axis. Since the function f crosses the horizontal axis where f of x equal to 0, so y is always 0. So horizontal intercepts a value of the x that makes f of x equal to 0. If the f of x equal to 0 when x equal to a, we say that the constant value of a is a horizontal x-intercepts of function. So we can also say that the x equal to a is a root 0 of the functions. So in number 9, for the graphing representation, determine if y is a function of x. So y is a function of x. So y is a function of x, which means the same x should go to 1y, but as you notice here, that from the, let's say, about the 2, so 2 actually goes with this y's and also this y's. So which means it's not going to be a function. But if you say x is in function of f, which means x is a function of, x is a function of y, now we are looking at the different form. Okay, so different form is this way though. So from here, now the 3, so going to the kind of changing here. So 3 is matched as this only x. And then the maybe 2 only go to this x, And then so because of that, x is a function of the s? Yes. X is a function of y, but not the y is a function of x this time. And the easier to find it is actually the way you call the vertical line test. When you vertical line, do you see all two intercepts on the graph? That's why it's not going to be the function of y is a function of x. But if you do the other ways, so which is this way, you only see the one intersection from the between the horizontal line this time and then the plane. So that's why there is a function of that. And then number 12, without using a graph calculator, determine the domain and range of the following functions. So domain and the range of function, but number 9 is a linear function. So linear function is always the domain is of your number, and then you get all different y value too. All right, because of linear. Because this function is going to be your line going to be this way. So yeah, it takes it anywhere you want. Okay, but the b is square root function. So square function is we can use all the domains because when you have a square root of -1, it becomes I, which is not a real. Okay, so whatever number inside x minus 4 should be greater or equal to 0. So x must be always greater or equal to 4. So that's a domain. And then the range, if you do that, you get the y is going to be greater or equal to 0 this time. So that's actually the domain range, okay? And then C is we call the rational function. As a rational function, only we need to eliminate the domain from when that x value makes the undefined case. So undefined is something over 0. So this is undefined. So when you get the undefined, we can take that x from the domain. So in here, if you look at the x minus 5, which is if you solve for y, solve for x is a 5. So when you plug it in b of 5, you get the 5 minus 5 over 5 minus 5, which is a 0 over 0. Because this 0, it is undefined. So all real number, for the case size, all real numbers except x equal to 5, which is, you can say it's everywhere is okay except x cannot be a 5. So you can say that. And for the D, Okay, so domain is about how many axes covered by graph. So graph is covering up to here, as you notice, right? Isn't it? You can match this one to here to here. So I can say domain is from -4 to up to -1. And also graph start from here up to here, right? So which is when you look at the x-axis is gonna be covers 1 through 3. So that's a domain. And also the range, you gotta use the y-axis. The y-axis cover from here. So it's here and it's up to here, right? So this is actually, you can see it. And also it's from here to up to here. Let me see, up to here, right? So this has been covered by the graph. So it's gonna be from the negative, it's gonna be -1.5 to the 0. Okay. Oh, I didn't see. Hold on a second. Oh my god, there's one thing in here. So there's a more that I needed added. Okay, so from here, union, which is, okay, let me write down. Okay, sorry about that. Yeah, I didn't see those. Okay, sorry. So there's a more. So over here, and also covering by this thing, right? So from the domain is -4 to -1, and then from the, so let me erase it, okay? So I can't see well here. So it's gonna be, yeah, that's more line here. So -0.5 to 0.5, and union, also another interval from the 1 to 3. As a range, same thing too. Yeah, I forgot about this one though. So lower than this point. So as a range, it's gonna be the by itself. Yeah, so we have to put the 3.5 negative to the negative 3.5, and then union of from the -2 -1.5 to 0, and then yeah, up to the 2 and then the actually 6. All right, so that's a range. So it's up to how you checked it. Okay, so this is a range from here to here to here, and then for the domain is, it's gonna be from here to here, here to here, and then from here to here. Okay, all right, this is how we cover from the. All right, thank you for listening.